Hi, today we are going to do notes for lesson 27. We are going to talk about some word problems, and the types of problems we are going to talk about are mixture and solution problems. You are going to see these types of mixture and solution problems in the future, and I'll give you some keywords so that you know what to search for when you need support on this information again. In our video today, I'm going to be using words like percent, solve. I'm going to be using the word of a lot. And even though you know these words in certain contexts, today I'm going to use these words in relation to our work in math. And I'm going to clearly point out how this word is used when we do our math work today. Okay. So make sure that not only do you have these words written down in your notes, you can pause and write them down, but when we use them in a different context, that's what you take notes on. Okay. We are going to be dealing with solutions and mixture problems. When you need to refresh your memory on this subject in the future, you can either search for this video again, or you can look up something called the bucket method, which is what I'm going to be using today to organize our work. There's one thing to just get the problem right, but there is another thing to organize your work so that you remember how to do this, and so that your work is clear, so that when you share your information, other people will be able to understand it as well. So let's read over this, and we're going to annotate this word problem. First, example 1. How many liters of a 20% alcohol solution should be added to 40 liters of a 50% alcohol solution to make a 30% alcohol solution? So as I just scanned through this problem, I'm seeing that there are some percentages. Then I see there are 3 percentages, and then I see a number that does not have a percentage but has a quantity, liters. And then there's a solution, and then there is added to. So I know I'm going to be adding at some place. So for all of our solution and mixture problems, the reason why it's called a bucket method is because we are going to make 3 buckets. One bucket, I'm actually going to move this bucket down a little bit more. One bucket, another bucket that we're adding, and that's going to equal to a final bucket. And this bucket that we are going to use, this one is going to be our starting solution or mixture. This is what we're going to add to our starting solution and mixture, this bucket, and we're going to get the end mixture, the end result. So that's how we are going to use these 3 buckets today in both of our examples. Okay, I'm going to move this guy over here. And I'm going to show you how we use that. So again, I'm going to draw my 3 buckets. So I have a 20% alcohol solution, and then I need to add to a 40-liter solution that has a different percentage, and it's going to equal some other solution. So let me show you how I fill this out. What do I start with? I start with how many liters of a 20% solution should be added. So this 20% solution is going to be our add, our middle one. So instead of 20%, I'm going to write 20% as in 100. So this is where my 20% is. I rewrote it as a fraction. This will be helpful. It will be clear if you write it as a fraction. So this needs to be added to 40 liters of a 50% alcohol solution. So 40 liters, I start with 40 liters, but it's of a 50% solution. So 50 over 100. So I'm writing my percentage, and this is the quantity of my material or my mixture. Together, they need to make a 30% solution. So I'm going to write my 30 over 100 here. My end result will have 30% of my solution. I don't know how many liters I'm going to add in here. So how many liters? This is my find. And my find is my variable, x. Now, what's my end result? I started with 40 liters of a substance, and then I added a certain amount of a substance. So my end result is going to have the 40 liters plus however many liters I put in at the end. So if you look here, inside the boxes are the quantities of the solution or the material. The top over here is the percentage, how pure or the percentage of a certain solution in that water. Okay, this is how it works. In this problem, I also read 40 liters of. Of is a super important word. In our context in math, of means to multiply. Of means to multiply. So that's a big hint. So now let's set up this problem. We have 50% of, this is not a 0.4, we have 50% of a 40 liter solution. So it's going to be 50 over 100 times 40. And I wrote 40 up here because I know that there's an invisible 1 down here. Okay, plus 20% per cent of some other solution we're going to add in, and that is going to equal 30% per cent. Every time I say per, I draw a bar, and that is going to be of 40 plus x. And then I'm going to draw a 1 down here because I know that there is an invisible 1 in the denominator. Now I'm going to go ahead and solve this problem. This is a problem that we have rational expressions, only rational numbers. We don't have any variables in the denominator, which is good. So I'm going to combine each term to start simplifying. So I have 2000 over 100 plus 20x over 100 is equal to, I'm going to multiply this, get 12, 2 zeros, plus 30x over 100. Now that I have a common denominator, I say, now what? I have a common denominator, now what? And you say, we set the numerators equal to each other. If you have not written that down in your notes before, you are going to write it down right now. When you have a common denominator, what do you do next? You set the numerators equal to each other. So you have 2000 plus 20x is equal to 1200 plus 30x. Now, if you need to make a note of this when you're annotating, you're going to say, use inverse operations or use Algebra 1 skills. And you're going to isolate the variable by combining all the variables to one side, all the numbers to one side. Equals 1200 plus 10x. And then I'm going to subtract 1200 from both sides, and I'm left with 800 is equal to 10x. Just have enough room to divide 10 to get 80 is equal to x. Great, I solved for x, but what does that mean? So you should write a sentence describing what that means. Whoa. The amount of 20% solution I should add to my mixture, we're dealing with mixture problems, is 80 liters. Oh, no. Okay, let's see. The amount of 20% solution I should add to my mixture is 80 liters. At this point, I want you to go back and I want you to summarize how we use this bucket method, what do each of these boxes mean, and what do these fractions mean. And then I want you to pause this video and then move on to the next video, for example, 2. Bye.